A rectangular sheet of paper with perimeter 39 centimeters is rolled into a right cylinder. If x represents the length of the paper, that then becomes the circumference of the open base of the cylinder. The volume of the cylinder is given by v equals pi times the square of x divided by 2 pi times the quotient of 39 minus 2x and 2. Using a graphing calculator, determine the domain, the length of the paper x that maximizes the volume, and the maximum volume. I've already set up the graph in Desmos. For each point on the graph, x represents the length of the paper, and v represents the volume. Let's focus on the x-intercepts. On the left we have 0, 0. On the right we have 19.5, 0. It is between these values where we have a positive volume, and therefore the domain is going to be the open interval from 0 to 19.5. We don't include 0 or 19.5 because at these values the volume is 0. So again, the domain is going to be the open interval from 0 to 19.5. As x increases from 0, notice the volume increases. Then we reach a maximum volume at this high point, and the volume starts to decrease. At this high point, notice x equals 13, and the volume is approximately 87.4159. The 13 represents the length of the paper that will maximize the volume, which is 13 centimeters, and the approximately 87.4195 is the maximum volume in cubic centimeters. So again, the domain is the open interval from 0 to 19.5. The length of the paper x that maximizes the volume is 13 centimeters, and the maximum volume is approximately 87.4159 cubic centimeters. I hope you found this helpful.